So negative x plus h squared, I agree, minus 3 x plus h and plus 1. So then, what will be the next step, please?
Negative x plus 2x
Good,
plus h squared
good,
minus negative.
very good. And now we have to distribute the negative sign, or negative 1, whatever you want to say, it's the same thing. Good, so now we have all three pieces. Let's put everything together. So this piece is what we just determined. So I have to copy the whole thing. Negative x squared minus 2xh minus h squared minus 3x minus 3h plus 1. We already multiplied this by negative 1, which is good, but be very careful. You have to put plus x squared plus 3x minus 1. So now the question is, remember, two things have to happen. What? What is the first thing that has to happen? Hold on 1 second. Give me 1 second. I'll come back and I'll answer your question. So what is the first thing that has to happen now? All terms that do not have h, must cancel out. Do they? Otherwise, we know there is an error somewhere.
Yes.
Yes. Okay, so x squared with negative x squared, positive 3x with negative 3x, and negative 1 with positive 1. So the first thing happened that we were expecting it to happen, right? All terms without h go away. They simplify. Not cross out, but you can say that, but they simplify. Good. So now we see three remaining terms. Okay, what is the next step? Awesome. And that's how the h from the denominator gets simplified with an h from the top. The final answer will still have h in it. So what do we have left? Negative 2x minus h and minus 3. And that's the final simplified form. This represents the rate of change of this function between two close points together. Good. Any questions on this? The next major topic of this section is graphing piecewise defined functions. And then we'll stop. Any questions for me? Anything? Is everything clear now? Okay, awesome. Piecewise defined functions. Piecewise defined functions. First of all, what is it? And can we come up with an example in real life? It's a function defined in pieces, at least 2 pieces. It can be 3 pieces, it can be 4 pieces, it can be 5 pieces. It's defined by several functions. It's defined in pieces. Okay. Do we have an example in real life? I can give you an example in real life, although I will make up the numbers because I really don't know percentages. So for example, it's a tax code. For people who make between $0 and $20,000 a year, they pay 2% in taxes. I'm making up the numbers. For people who make between $20,000 and $50,000, they pay 4% in taxes. For people between this and this, they pay another percentage. That's a piecewise defined function. For particular x values, a function. For another set of x values, a different function. For another set of x values, another function. That's a piecewise defined function. So I'm going to pick one from page 252, and then feel free to pick another. I'm going to start with 64. I want to show you a mechanism or what I think it's easy a method to understand and how to graph these. If you have a different one, do not switch to mine. Just watch. If you find it easier, switch to mine. If you don't find it easier, do not. I'm fine with that. Do not change something that works. Okay. Is this a piecewise defined function? The answer is yes, because it has two different functions. For x values from negative infinity to negative 3, the function is this. And for x values, can anyone give me the interval notation for this?
Step.
The interval,
That'd be a bracket.
of course.
Negative
Yes? Comma?
infinity.
Awesome. Great job. So for x values between negative 3 and infinity, this is the function that we are going to look at. Now I'm going to ask you about the domain of this function. Every time we're asked to graph. So the question here is graph it. It's a piecewise defined function, graph the function. So every time we are asked to graph a function, we have to find its domain first. So looking at this, what will you say the domain is?
Negative infinity.
2? Exactly. Awesome. Well done. So let's start the table. Again, if you're used to use a vertical table, I'm fine with that. I prefer a horizontal table. But that's just my preference. You do whatever you think is good for you. I will put the domain. Which x value do you think is the key here? I can plug in any x value I want because the function is defined on all real numbers. But which x value is the key? Something major happens at that value. Right, indeed. What happens at that value? The function changes from this to this. Where? Exactly at negative 3. Notice one thing that, of course, 0 will always be in the table, but negative 3 is the key x value. Notice the symbols. A left parenthesis to the left and a right bracket to the right. Right immediately under 3, negative 3, I will write exactly what I see. A parenthesis facing left and a bracket touching the parenthesis facing right. I copied this here and I copied this here. Why? In a minute it will be very clear. Next I'm going to ask you, I just want to put right on top of the table, I would like to put the functions in the correct order. Looking at the function that is piecewise, can you please tell me which function will be used for x values between negative infinity and negative 3? Which branch? Which of the two functions we see here? Yes? Perfect. X plus 2. I know it's an overkill. Just bear with me. Because I have them here, but sometimes they may not be arranged in the correct order. That's why it's safe to write them on the table. Okay, so now I know it's a silly question. Which function do I use from negative 3 to infinity? Of course, x minus 2. Remember, the piecewise defined function may have more than 2 branches. It may have 3, it may have 4. Okay, very good. So now this is a linear function as well as this. I'm going to use negative 4, plug it in, and then negative 3 and plug it in. When I will ask you to plug in negative 3, you will say, no, I disagree, because negative 3 is not here. Negative 3 is here. But if you don't plug in negative 3 in this branch, then you will have to plug in negative 3.0000000000001, the first number on this side. Instead, we're going to plug in negative 3. So first of all, let's plug in negative 4 and give me the y value. Good. So let's plug in negative 3 and give me the y value, and I will be writing it inside the parenthesis. Negative 1. Negative 3 on the other side, please tell me the value and please write it inside the bracket. I agree. Perfect. Let's plug in 0. Good. And also let's plug in 2 because these are the x and y intercept. 0. Ready to graph. from left to right, please give me the first ordered pair that we have to plot. -4, -2 it is. 1, 2, 3, 4, 1, 2. It's this point. The next ordered pair. So -3, -1, but I need to know whether this will be a full point or that open point that we saw in the graph a few minutes ago. Very good. And this is the graph, and you understand that you cannot extend it to the right-hand side of -3. That's why I specifically told you, and you gave me the correct answer, between -infinity and -3, I will graph x plus 2 and nothing else. The next ordered pair, we graphed this as an open point. Now we have this to graph or plot. What is it? Yes, so it's -3, -5, and it is a full point or closed. Perfect. The next ordered pair. Very good. The next ordered pair. Very good. And this is it. And this is our f of x. And this is the piecewise defined function. Please make sure you're, yes, please.
So, in my pre-calc class,
Yes?
my teacher had us extend it and then shade like above or below the line. I don't know if that's basically to say like anything like in the shading.
Did you use two charts, two tables?
I think so.
If that method works for you, please use it. If the graph is the same, it's fine.
Okay.
Yeah. Do not reinvent the wheel. Do not change something that works. I think that is confusing, and you may not be able to find the open and the close point correctly. But if it works for you and you do find it correctly, I'm very happy. Whatever works. Any questions? Okay, so let me show you what we accomplished today.